Everything I've told you about the Habsburgs, the deformed jaws, the infant mortality, the genetic disorders, you might think that's a history lesson. It's not. In 2026, roughly 10% of the global population lives in communities where consanguineous marriage is practiced. In some regions, the rate of first-cousin marriage exceeds 50%. And the genetic consequences being documented right now by modern researchers are identical to what destroyed the Habsburg dynasty. That word, consanguineous, just means marriage between close biological relatives, most commonly first cousins. And I don't mean a few hundred people tucked away in some remote valley nobody's heard of. I mean entire nations, hundreds of millions of human beings. A parallel Habsburg experiment running in real time, across continents, tracked by modern medicine with a precision that Charles II's physicians couldn't have dreamed of. So where does the 10% figure come from? One man, one life's work. Professor Alan Bittles, a geneticist at the Center for Comparative Genomics at Murdoch University in Perth, Australia, spent more than 4 decades building what is probably the most comprehensive global dataset on consanguinity ever assembled. His database, consang.That, pulls from studies spanning dozens of countries. His estimate, published in the Proceedings of the National Academy of Sciences, 10.4% of the world's population is either in a consanguineous union or is the offspring of one. That's over 750 million people walking around right now with elevated genomic homozygosity because their parents shared a recent common ancestor. But here's the number that really unsettles. Roughly 20% of humanity, 1 in every 5 people alive, lives in a community where cousin marriage isn't just tolerated, it's preferred. Not a relic clinging to the margins of modern life, a living, breathing, reproducing norm. Now let me give you the map, because when you see these numbers country by country, the abstraction turns into geography, and geography has consequences. Pakistan. Consanguineous marriage rates between 50 and 60% of all unions. In the provinces of Punjab and Sindh, first cousin or second cousin marriage hits 65%. Saudi Arabia, 51 to 57%, despite a mandatory premarital genetic screening program that's been running since 2004. Iraq, 47 to 58% depending on the province. Sudan, over 50%. Qatar and the UAE, 40 to 54%. Iran averages 38 to 40% nationally, but its southern and western provinces blow past 50. Egypt sits around 33 to 39% overall, with Upper Egypt exceeding 40. Parts of southern India, Tamil Nadu, Karnataka, Andhra Pradesh, still practice uncle-niece marriages at rates between 20 and 35%. And Turkey shows a dramatic split. Istanbul and the western coast report 8 to 10%, while eastern provinces near the Syrian and Iraqi borders exceed 40. These aren't all the same thing genetically. That distinction matters enormously. A first cousin marriage, the most common form worldwide, produces a child with an inbreeding coefficient of 0.0625, meaning 6.25% of that child's genome is expected to be identical on both copies because both parents inherited it from the same ancestor. A double first cousin marriage, where 2 siblings from one family marry 2 siblings from another, and then their children marry each other, doubles that coefficient to 0.125. An uncle-niece marriage, still practiced across southern India and parts of the Middle East, also hits 0.125. That's not academic fine print. That's the difference between a loaded weapon and one with the safety already off. Hold those numbers. You're going to need them. And before anyone tells themselves this is about faraway places and different worlds, let me take you to Bradford, England. West Yorkshire, a post-industrial city with full access to the National Health Service, modern education, and every tool modern genetic science has to offer. The British Pakistani community in Bradford has maintained consanguinity rates estimated at 55 to 59%. Not in Pakistan, in England. In a city where genetic counseling exists, where hospitals have pediatric genetics departments, where the information is available to anyone who asks for it. That data comes from one of the most important health studies running anywhere on Earth, and it's about to become the centerpiece of everything I'm telling you. But first, the Habsburg numbers. You've seen them before if you've watched the earlier episodes in this series. I need you to see them one more time. Not for the emotion this time, for the math. In April 2009, Gonzalo Alvarez, Francisco Ceballos, and Celsa Quintero at the University of Santiago de Compostela published a study in PLOS One that did something nobody had done before with this level of rigor. They constructed a genealogical database of over 3,000 individuals across 16 generations of the Habsburg dynasty and calculated the inbreeding coefficient for every single member of the Spanish line. The trajectory they revealed is a dynasty graphing its own extinction. Philip I, founder of the Spanish Habsburg line. Inbreeding coefficient 0.025. Modest. The kind of background intermarriage you'd find across European royalty. Nothing alarming. His grandson, Philip II, 0.040. Still within normal bounds for aristocratic families who occasionally married distant relatives. Then the curve bends hard. Philip III, 0.218, a staggering leap. And then Charles II, born in 1661, the last of the Spanish Habsburgs. Inbreeding coefficient, 0.254. Let that register. The theoretical coefficient for a child born to a parent and their own biological offspring, the most extreme form of inbreeding possible, is 0.250. Charles II exceeded that number. He was more inbred than the theoretical product of incest, not because of one catastrophic union, but because generation after generation of uncle-niece marriages and double first-cousin marriages had folded the genome back on itself until recessive mutations buried in every human lineage had nowhere left to hide. You know what happened to his body. You've seen the portraits. The Habsburg jaw, mandibular prognathism combined with maxillary deficiency, the defining feature of the dynasty's portraiture, the thing that stares at you from every canvas. Charles sat at the extreme end of that deformity, so severe he could barely chew food. In 2019, Roman Vilas and colleagues published a study in the Annals of Human Biology that used facial analysis of Habsburg portraits, and they confirmed a statistically significant correlation between each family member's inbreeding coefficient and the severity of their jaw deformity. The more inbred, the worse the jaw. A perfect, terrible gradient. Charles sat at the bottom of that gradient. He also suffered repeated bouts of illness throughout his life, probable intellectual disability, and a constellation of symptoms so complex that a 2021 case study in BMJ Neurology Open tentatively attributed them to aspartyl glucosaminuria, a rare autosomal recessive lysosomal storage disorder. 2 marriages, 0 children. He died November 1st, 1700, at age 38. The Spanish Habsburg line died with him. But Charles wasn't an outlier. He was the endpoint, the culmination. Alvarez and his team documented an infant mortality rate among the later Spanish Habsburgs reaching 30%. Children dead before their first birthday. The expected rate for comparable Spanish populations of the same era was roughly 20%. That persistent 10 percentage point gap is the fingerprint of inbreeding depression. Not war, not plague, not assassination. Biology. The dynasty also experienced declining fertility, fewer children per union, an increasing proportion of marriages producing no surviving heir at all. The Habsburgs weren't conquered, they weren't overthrown. The biology simply couldn't sustain itself. Those are your control group numbers. Memorize them, because you're about to see them again in data collected this decade from cities you could drive to. In 2007, a physician named John Wright began enrolling pregnant women at Bradford Royal Infirmary in what would become the Born in Bradford study, a cohort investigation tracking over 13,776 pregnancies, making it one of the largest birth cohort studies in the United Kingdom. Wright and his team weren't exclusively focused on consanguinity. They were casting a wide net: genetics, environment, poverty, ethnicity, diet, mental health. The full spectrum of factors shaping childhood outcomes. But the consanguinity data that emerged from their research became the single most important modern dataset linking cousin marriage to measurable genetic harm in a Western healthcare setting. The key findings were published by Eamon Sheridan, John Wright, and their colleagues in The Lancet in July 2013. They examined 11,396 babies born in Bradford. 37% of all babies born to Pakistani origin mothers were the offspring of first cousin marriages. The headline result? Babies born to first cousin parents had roughly double the risk of congenital anomalies compared to babies born to unrelated parents, 6% versus 3%. That doubling held after the researchers controlled for socioeconomic deprivation, maternal education, maternal age, and every other confounding variable they could measure. This matters because the instinctive objection is always, that's just poverty, that's just lack of healthcare access, that's just poor nutrition. No. Sheridan's team accounted for all of that. Consanguinity wasn't a proxy for poverty. It was an independent risk factor. Full stop. And it accounted for 31% of all congenital anomalies among babies of Pakistani heritage in Bradford, nearly 1 in 3. The specific conditions documented: congenital heart defects, neural tube defects, limb abnormalities, and a spectrum of autosomal recessive metabolic disorders, the kind where a single defective gene does nothing, but 2 copies of it devastate a child's body. The study didn't stop in 2013. Those babies grew into children. The follow-up data showed children of consanguineous unions continuing to show elevated rates of hearing impairment, visual impairment, and developmental delays as they aged. The researchers kept reiterating a point the public kept missing. A child of first cousins carries a 6% chance of inheriting a recessive disorder, compared to 3% for the general population. That sounds modest. It isn't. Because in communities where cousin marriage has been practiced across multiple generations, the cumulative risk doesn't stay flat. It escalates. Each generation starts from a higher baseline of homozygosity. The latter only goes up. And Bradford isn't the only data point. Not even close. In Saudi Arabia, a 2024 review published in Curious by Al-Harbi and colleagues compiled evidence from multiple Saudi studies and found consanguineous unions associated with significantly elevated rates of sickle cell disease, thalassemia, cystic fibrosis, spinal muscular atrophy, phenylketonuria, and a cluster of rare metabolic disorders so prevalent in certain Saudi communities that dedicated national screening programs now exist specifically for them. One finding from that review deserves its own paragraph because it's almost incomprehensible in scale. More than 1/3 of all healthcare resources in Saudi Arabia are allocated to patients with genetic, chromosomal, or congenital disorders. Not 1/3 of genetics funding, 1/3 of all healthcare spending, across the entire national health system. That is the economic weight of sustained consanguinity across an entire national population. And it is, to be blunt, a number the Habsburgs would recognize if they could see it, because genetic burden was the thing that slowly strangled their dynasty's capacity to function, financially, politically, biologically. The mechanism is the same. The scale is different. The scale is worse. Which brings us to the mechanism itself. And this is where the mathematics closes around you like a trap, because once you understand how inbreeding coefficients accumulate, you can't unsee it. One first cousin marriage, inbreeding coefficient 0.0625. Manageable. Now imagine that child grows up and marries their own first cousin, because in their community, that's normal. Expected. Their parents did it, their grandparents did it, their great-grandparents did it. The child of that second-generation consanguineous union doesn't just add another 0.0625, it compounds. Because both parents already started with elevated homozygosity, the shared ancestry doubles back on itself. After 3 successive generations of first cousin marriage, an individual's inbreeding coefficient reaches 0.125 to 0.146. After 5 generations, 0.20. After 7 to 10 generations of sustained first cousin marriage within an endogamous community, the coefficient enters 0.25 territory, Charles II territory. And this isn't theoretical modeling on a chalkboard. Modern genomic tools let researchers see this accumulation directly, written into actual human DNA, through structures called runs of homozygosity. These are long, unbroken stretches of the genome where both copies of a chromosome are identical, inherited from the same shared ancestor on both sides of the family. A 2018 review by Ceballos and colleagues in Nature Reviews Genetics explained that runs of homozygosity have revolutionized consanguinity research because they provide a direct genomic readout of real inbreeding, regardless of what any family pedigree says. Pedigrees can be incomplete. They can omit unions. They can lie. DNA can't. In populations with sustained consanguinity, ROH studies consistently reveal total homozygous stretches indicating multi-generational inbreeding. Studies of Pakistani, Middle Eastern, and North African populations have found average runs of homozygosity significantly exceeding those in outbred European populations, with some individuals showing genomic profiles consistent with inbreeding coefficients of 0.10 or higher. That's Philip III territory, and climbing. Here's why that should terrify you on a biological level. Every human being, every single one of us, regardless of ancestry, carries an estimated 5 to 10 lethal equivalent recessive mutations. Mutations that, if present in 2 copies, would cause severe disease or death. But they sit there harmlessly in most of us because we only have 1 copy. The other copy of the gene works fine and picks up the slack. You don't know they're there. They're silent passengers. In an outbred population, the odds that both parents carry the exact same rare recessive mutation are vanishingly small. The genetic lottery protects you. But when parents share a recent common ancestor, like first cousins who share a set of grandparents, the probability that both inherited the same recessive mutation from that ancestor spikes dramatically. At an inbreeding coefficient of 0.0625, about 6.25% of the child's genome is homozygous by descent. The silent passengers start getting a chance to speak. At 0.125, the chance doubles again. At 0.25, Charles II's territory, a full quarter of the genome is homozygous by descent, and the probability that multiple recessive disorders manifest simultaneously becomes not just possible, but expected. Probable. Almost certain. The Habsburg trajectory and the trajectory of modern consanguineous populations aren't merely similar. They're the output of the same mathematical function applied to the same biological substrate. The Habsburgs compressed extraordinary inbreeding into roughly 2 centuries through aggressive uncle-niece and double first-cousin pairings within a tiny royal pool. Modern consanguineous communities reach comparable levels over a longer timeline, through sustained first-cousin marriages across many generations within larger but still endogamous populations. The road takes longer. The destination is the same. So let me run the parallels, condition by condition. Habsburg symptom by modern data point. The Habsburg jaw. Mandibular prognathism and maxillary deficiency, the defining feature of the dynasty's portraiture. Modern consanguineous populations show elevated rates of craniofacial anomalies, including cleft lip and palate, at 1.5 to 2 times the rate found in children of unrelated parents. The specific Habsburg phenotype, that particular thrust of the lower jaw, was shaped by particular alleles concentrated within a tiny family gene pool. But the broader principle is universal. Craniofacial development relies on dozens of genes harboring recessive variants that only express themselves when homozygous. Increase homozygosity, increase craniofacial malformation. Every time. Habsburg fertility decline. The increasingly desperate, increasingly unsuccessful attempts to produce heirs. 2 marriages for Charles II. 0 children. Modern research documents higher rates of spontaneous abortion, stillbirth, and primary infertility among consanguineous couples. Studies published in the Proceedings of the Royal Society B found measurable reductions in reproductive success that persisted after controlling for socioeconomic variables. Inbreeding depression doesn't just attack one aspect of fertility, it degrades the entire chain. Gamete viability drops, implantation rates fall, fetal survival decreases. The system fails at every checkpoint. Habsburg immune vulnerability. Charles II's lifelong susceptibility to illness. The infections that swept through Habsburg nurseries and killed infants who should have survived. Several primary immunodeficiency disorders, severe combined immunodeficiency, chronic granulomatous disease, are autosomal recessive, and their prevalence is markedly elevated in consanguineous populations. Studies conducted in Saudi Arabia, Iran, and Turkey have documented these immune disorder clusters at rates far exceeding those in outbred populations. But it goes deeper than specific diseases. Homozygosity across the major histocompatibility complex, the sprawling gene region governing your immune system's ability to recognize threats, reduces the diversity of immune responses. Your body loses its ability to fight a broad range of pathogens. The Habsburgs kept getting sick. Their immune systems were genetically compromised. The science now explains a pattern that baffled their physicians for 200 years. And Charles II's intellectual disability? The thing that made him nearly incapable of governance, that turned the most powerful throne in Europe into a chair occupied by a man who could barely function. Multiple studies across different consanguineous populations find that children of first-cousin marriages score several IQ points lower on standardized tests compared to children of unrelated parents from the same communities, after controlling for socioeconomic status and parental education. But the average isn't the real story. The real story is the tale of the distribution. The rate of severe intellectual disability, IQ below 50, is markedly elevated in consanguineous offspring, reflecting the unmasking of recessive alleles governing neurodevelopment. Not a subtle cognitive dimming, a catastrophic one. Charles could barely govern. Same math, same outcome, different century. These aren't loose metaphors. They're the same equation producing the same results 400 years apart. But data alone doesn't reach people. People reach people. And the most devastating voices in this story aren't outsiders pointing fingers at communities they don't belong to. They're insiders who chose to speak. In Bradford, the Born in Bradford study didn't materialize from a university researcher's curiosity alone. It grew from a community that already sensed something was wrong. Pakistani heritage families in the city were disproportionately represented in pediatric genetics clinics and childhood disability services. Parents were showing up with 2, 3, 4 children affected by the same rare condition. In reporting coinciding with the 2013 Lancet publication, Bradford families described having multiple children affected by genetic disorders, conditions their doctors linked directly to both parents sharing recent common ancestry. These weren't families speaking from shame. They wanted awareness. They described watching children struggle with hearing loss, visual impairment, and developmental delays. They described the slow, gutting realization that marriages arranged within their extended families, marriages made with love, with cultural purpose, with the full weight of tradition behind them, carried a biological cost nobody had ever explained to them. That last part is critical. Nobody had explained it. Not a doctor, not a community leader, not a teacher. The information existed in genetics textbooks, in academic journals, in Bittles' database. It didn't exist in the conversations that mattered, the ones between parents planning their children's futures. Genetic counselors working in Bradford and other UK cities with large South Asian populations have described in published interviews and anonymized case reports a pattern that recurs and shatters you every time you encounter it. The same rare autosomal recessive condition appearing 3 and 4 times within a single extended family. Conditions so uncommon in the general population that a clinical geneticist might encounter one case in an entire career, clustering in a single family tree because that family tree loops back on itself, because the branches reconnect, because the pedigree, when you draw it on paper, looks less like a tree and more like a web. And if that image sounds familiar, it should. It's the Habsburg family tree. Same loops, same consequences, different names. So what's being done? Because this story can't end in despair. The Habsburgs had no option for a different ending. We do. Saudi Arabia made premarital genetic screening mandatory in 2004. Every couple gets tested for sickle cell disease, thalassemia, and other common recessive conditions before the marriage contract is finalized. The program hasn't eliminated consanguineous marriage. Rates still exceed 50%. Many couples receive the results, understand the risk, and proceed with the marriage anyway. But the program has given people something the Habsburgs never had. Data. Information. A chance to make a choice with open eyes rather than closed ones. And some couples do change course. Cyprus offers what might be the most striking success story. In the 1970s, the island had one of the highest rates of thalassemia major in the world, a devastating autosomal recessive blood disorder, a direct consequence of the high carrier frequency within its relatively small endogamous population. The government implemented a carrier screening program combined with genetic counseling, and within a single generation, the birth rate of children with thalassemia major dropped by over 95%. It didn't require banning anything. It required information. It became the global model for how genetic screening can transform population health outcomes without coercion. In Bradford, the Born in Bradford study itself has become a public health intervention, not by telling anyone who to marry, but by making genetic counseling available, accessible, and designed with cultural sensitivity at its core. John Wright and his team have been explicit about this. They aren't in the business of condemning cultural practices. They're in the business of giving people information. And they've watched, over more than 15 years now, as awareness within the Bradford Pakistani community has grown. Slowly, imperfectly, but measurably. And that, right there, is the chasm between the Habsburg dynasty and the world we're living in right now. The Habsburgs didn't know. They couldn't have. Gregor Mendel wouldn't publish his foundational work on heredity until 1866, more than a century and a half after Charles II's death. The concept of recessive inheritance didn't exist when the Habsburgs were arranging the uncle-niece marriages that would destroy their bloodline. The idea that you could calculate an inbreeding coefficient, map runs of homozygosity in a genome, or screen a couple for carrier status before they had children was centuries away from being imagined, let alone implemented. They had no science to warn them, no mathematics to quantify the risk. They didn't even have the vocabulary to describe what was killing them. We have something else entirely. We have Alvarez's Habsburg pedigree analysis that quantified the dynasty's genetic collapse with mathematical precision. We have Bittles' 4 decades of global consanguinity data documenting the scope of the phenomenon. We have Sheridan and Wright's born in Bradford data proving the health consequences in a modern Western population with access to modern healthcare. We have Ceballos' runs of homozygosity framework showing us the accumulation in real genomes. We have premarital screening programs that demonstrably work when they're funded and implemented. Cyprus proved that beyond argument. We have genetic counseling that saves lives when people actually have access to it. The Habsburgs couldn't have known what was happening to their bloodline. They had no framework, no science, no theory of heredity. That ignorance wasn't a moral failing. It was a tragedy of timing, born too early for the knowledge that would have saved them. We don't have that excuse. We've measured it. We've mapped it. We've published it in The Lancet and PLOS1 and Nature Reviews Genetics. We've tracked it across 13,776 pregnancies in a single English city. We've watched the same curves that killed a dynasty reproduce themselves in modern data, in modern hospitals, in communities that have access to every tool the Habsburgs lacked. The question isn't whether the Habsburg pattern is repeating. The data already answered that, decisively. The question is what we do with the answer. Subscribe for more stories like this.